Hello and welcome to my talk on load testing AWS serverless architectures using serverless. My name's Ben Ellerby, I'm the VP of Engineering at Theodo and an AWS serverless hero, meaning I get to speak at conferences like this and produce a lot of content in the serverless space. If you're interested in any of the content I produce, feel free to check out the Serverless Transformation blog, podcast and newsletter. And I also run the Serverless London meetup with another AWS hero, Anne Stanley, and another speaker at this conference, Alex White, who also happens to work at Theodo. If you're interested in that serverless transformation brand of content, go to serverless-transformation.com. And if you're interested in Theodo and how we help people build with serverless, go to theodo.co.uk/experts/serverless. Now, before we jump in, I just want to go quickly over what serverless is. I'm sure a lot of you have been exposed to it in different ways, but it's one of those terms that means different things to different people. To me, it's an architectural movement. It allows us to build and run applications and services without thinking about the underlying servers. Developers can send application code that's run by the cloud provider in a completely isolated and abstracted way, and we can also leverage third-party providers for things like back-end logic and state management. For instance, Cognito for user identity management inside of AWS, or a service like Okta outside of AWS can do the similar thing. Now, there's also a framework with the same name, the serverless framework, which can make it a bit confusing when talking about serverless. But in this talk, we're really focusing on serverless, the architectural movement, rather than serverless, the infrastructure as code framework. Now, why do people take a serverless approach to building architectures? Well, first of all, there's a cost reduction. In the pay-per-use model, there's often a reduction in the actual overall cost of running your application. When it comes to operations, there's a lot less operations, and this isn't no ops, there's less ops. It can cost less and reduce the total cost of ownership of running your application, but also your ops team can then focus on more value-bringing activities than typical security patching and maintenance. Developers can also focus more on the business value. Rather than building code to manage infrastructure, they can focus on the business logic and new features that actually represent your unique value to customers. And it's scalable from day one with completely dynamic scalability, which we're going to see later on in the load testing element of this talk. And as we start to make a more efficient usage of the service in our data centers, I think serverless is going to help us reduce the CO2 impact of the architectures that we build. Now, Lambda is a typical poster child for serverless. The function is a service part, the compute element that runs code in response to different events. But there's also S3 for storage, DynamoDB for a completely serverless NoSQL database, API gateway for proxying requests through to those different serverless services, Cognito for user identity management, SQS for queuing, step functions for workflows, and EventBridge for building sort of a central event bus between your serverless microservices and also integrating with different partners. Now, the list goes on. These are just some of the usual suspects in building serverless architectures, but the key here is it's not just Lambda. There are different elements that come to build our serverless architecture. This gives us a great power and flexibility, but also can make it more interesting in how we test and make verifications about the scale that these architectures can support. This will typically result in a microservice-based serverless architecture, and typically these are event-driven. We see EventBridge being used more and more to connect completely serverless, event-driven microservices together, and we're going to look at a real-world application to see how we'd verify the scalability of something like this. Now, in terms of scalability, serverless scales differently, and in terms of load testing, that's going to impact what we're trying to verify. The pay-per-use model can be really interesting from cost saving, but can also mean your architecture might support a scale when people are trying to maybe denial of service your website, but that can lead to new concerns like denial of wallet, where you're actually just getting billed for a huge amount of scalability that you're dynamically supporting. AWS service limits, both hard and soft, can create issues in terms of how we're scaling. Those soft limits being things that we can raise that are there for our protection, and those hard limits being sort of the hard fundamental limits to where that service is at the moment. We can outpace the non-serverless components of our architecture. For instance, let's say there's a legacy relational database that's hanging around in our application. Maybe the rest of our architecture is going to scale too quickly and going to hit that with too many requests. And the same for third parties. We might scale so quickly we end up denial of servicing those third parties. And we obviously want to put in place measures so we don't do that. Cold starts can impact performance, especially when there are sudden spikes. So cold starts is that increased latency for the initial setup of a Lambda function before it's warm. This can be more impacting to customers when there's a sudden spike because there might be a lot of Lambda functions that are being invoked from a cold position. The combination of these different services in a completely distributed system also makes the bottlenecks harder to spot. When you had that big monolith and that big relational database, we kind of knew where the bottleneck was. As we're starting to build out these more scalable but also more distributed architectures, the bottlenecks can be more interesting to spot and more difficult to verify the scalability of. And finally, there is also a regional distribution of traffic, especially as we're dealing with very region-specific architectures in terms of AWS. It's interesting to see how we're going to scale when traffic's coming from different areas of the world. Now, load testing is another term that means different things to different people. For the purpose of this talk, we're going to talk about simulating different concurrent traffic levels on an application to verify its scalability. There are typically two types of load testing, protocol-based and browser-based. Protocol-based is simulating directly at the API level. Browser-based is spinning up browsers and simulating the user interactions with the browser to then trigger realistic protocol-level requests. Typically, serverless architectures are best tested at the protocol level because at the scale that we're testing, spinning up that many browsers and running through that many different browser scenarios is going to get quite expensive, slow, and hard to manage. And just to bear in mind, the protocol doesn't have to necessarily just be HTTP requests against something like API Gateway. We're typically starting to load test our different microservices by doing protocol testing directly at the AWS SDK level for things like injecting events into EventBridge, and there are different custom drivers that you can build to be able to do that, and I'll talk about that more at the end of the talk. Now, the key components to a good load test are typically it's against an exact replica of the production infrastructure. There's observability tooling in place. We can track the right metrics. The scenarios, which are the sort of different test cases that we're running, are completely repeatable. We can simulate a very high load, and we can also simulate realistic user flows. And finally, with that different multi-regional architecture, making sure there's geographic distribution of that load can also be interesting. To take a real-world example of a serverless architecture that we've built and load tested, let's look at Gamercraft. There's actually an article out on the AWS Game Tech blog recently where we wrote with Gamercraft to write up the approach and the serverless architecture. So if you're interested, feel free to check that out. But in short, Gamercraft enables amateur gamers to play in high-stakes games. It's really a tournament-building system on top of different esports games, and it allows a much fairer and more engaging tournament experience for a broader range of players. In terms of architecture, Gamercraft needed the ability to support a massive volume of users and accommodate traffic spikes from large-scale tournaments down to those low usage periods, and that's why they took a completely serverless approach, and we helped them build that out. So there's a sort of a microservice architecture that came from a domain-driven design exercise, but we have a tournament service, a notification service, a user service, a match service, a team service, and a prize service, and some common elements that are shared between. And EventBridge is the core event-driven sort of bus between those to enable the different services to communicate in a completely event-driven way. This resulted in an architecture that was quite elegant from a coding perspective. There were quite minimal pieces of code written, and most of it was sort of embodied in the architecture, but it also made an architecture that was slightly difficult to reason about when it came to load testing and spotting where potential bottlenecks could be. And this is quite typical of these very event-driven serverless architectures. So what do we want to test during our load test? Well, we want to validate that our cost estimates as loads increase are correct. Often when we're building serverless for high scale, we need to do a lot of cost modeling to make sure that the services are going to scale and it's going to be affordable. We want to identify any service limits that might need raising. It might be the number of concurrent Lambda functions or any other service that has different limits. We want to find if any of those haven't been raised yet but need to because they're a bottleneck to scalability. We want to find any AWS services that we're reaching the limits of. Quite rare, but it does happen from time to time, and we need to have coping mechanisms and queuing in place to deal with that. We want to verify that any third-party and non-serverless components are protected from spikes. Things like the circuit breaker pattern are massively useful here. We should have identified these before, but it's better to identify when we're giving them a heads up that we're doing a load test rather than completely out of the blue hitting them with too much traffic. And we want to identify any hidden bottlenecks. As I mentioned before, it can be more difficult to spot those bottlenecks. And we also want to verify the impact of regional distribution across different AWS regions. Now, how do we start? It's quite a lot to do, and the tooling needs to match the architecture, as typical load testing tooling might not be the best way to test this serverless architecture. Well, first of all, we need an environment to test against. I'm a big proponent of serverless flow. It's a CI/CD branching pattern that I've written about before, but basically for 100% serverless architectures, for every pull request, we can spin up a dedicated integration testing environment that's completely isomorphic, has the exact same shape as a production infrastructure. There's no mocking in place. We're running actual tests against the real AWS services, and this is how you get the best integration testing. Now, this same approach can be taken for load testing and allows us to have completely isolated load testing environments. And later on, as we start to have some basic scenarios where often load testing, it can be part of the CI/CD strategy to involve a load test before things go to production to make sure we're not introducing new bottlenecks. But in short, we want to have a dedicated isomorphic environment to production that is exactly the same shape and runs on exactly the same architecture. There can be some caveats here, third parties that might not be okay with you running load tests. Maybe we have to protect them or mock them out. And if we have non-serverless components, our architecture should already be coping with that, but we probably want to ascertain that before we hit them with too many requests. The next element to a good load test is going to be the metrics, the thing we're actually measuring to make sure we're learning something and validating some hypothesis. The basic ones for serverless, typically response time, error rates, and any throttling. So throttling being a particularly important one when it comes to Lambda. It's quite easy to get that from CloudWatch, and X-Ray can also give us sort of an end-to-end view of our request flows, which makes those distributed bottlenecks easier to spot when you use things like CloudWatch Service Lens. CloudWatch Lambda Insight is also quite new and quite interesting to look at. That can help us understand what our memory usage is like, what our network usage is like, as well as the basic function cost, duration, and number of invocations and errors. Moving outside of just the AWS tooling, there are a lot of dedicated serverless observability providers. Thundra, Epsigon, and Lumigo will do a great job at serverless observability, and having any of those in place can be great. And Datadog, quite a typical observability provider, is really growing out its serverless functionality and can be really useful for building out dedicated performance dashboards for during the load test to spot where the different issues could be arising. The next is having a load testing toolkit, the sort of system to be able to run the load testing. For a long time, I've really liked Artillery as a load testing solution. It allows for load testing and also smoke testing, and is typically used by SREs, those site reliability engineers, as well as developers and QA engineers. Typically, you have a test definition that looks something like this. We have a target that we're hitting, we have a number of phases, and we know what the ramp up is like. We can have a payload that can either come from sort of faked data, or it could come from anonymized data that we've previously had access to, and we can have a number of different flows that are using different parts of that data and hitting different endpoints, and then we can easily run that with something like Artillery run and then the definition.yaml. Now this is great, but when we get to a very high scale, my laptop's not going to be able to simulate the amount of traffic that we need. So typically we could again go and run this on a server, but as you probably got from the start of the talk, servers aren't the thing I get the most joy from. So how could we do this in a different way? Well, what if there was a service that can run code without us having to manage the servers and can support a massive amount of parallelism? Well, luckily, AWS Lambda does exactly that. And even more luckily, there's a service called Serverless Artillery that enables us to combine serverless and artillery to get, you guessed it, serverless artillery for instant and cheap, easy to perform load testing that I'm finding really effective for testing our serverless architectures. Now it looks something like this. We run SLSArt, serverless artillery, from our local computer that will then deploy and then enable Lambda functions to be controlled to send a massive amount of requests through to the target architecture. So serverless artillery combines artillery as a really great way to define those scenarios, but then also the sort of infrastructure wrapping around that to get it running on AWS Lambda to then go and trigger those requests. Now, one important thing here is as we're starting to use AWS services, in this case Lambda, to run our load test, we don't want the load testing infrastructure to impact the limits of our actual infrastructure under test. It can start to affect it, and we can also get more realistic traffic patterns by shifting this out to completely separate AWS accounts. And when it comes to multi-regional testing, shifting out to run this from different regions can also help us start to verify what the impact is of traffic coming from different areas of the world. But in this case, we're really trying to make sure we're not limiting our scalability by the sort of infrastructure, the load testing infrastructure, taking up some of the service limits for things like Lambda concurrency. Another point to mention here is the committing of experiments. So all tests should be repeatable experiments. Treat them like a science experiment, have a hypothesis, verify its outcome. The context of every test, the scenario template, and the result should all be committed to a repository. This allows an analysis in the future to make sure that we've not impacted scalability or to understand where scalability has been impacted. And it also allows the experiments to be repeatable, which puts a lot more trust in their validity. In conclusion to what you need for a good load test, well, you need a isomorphic environment to production, we need a way to track the right metrics, and we need a toolkit, and serverless artillery is a serverless way to run our load tests at a good amount of scale and a nice level of abstraction. Just one heads up here, you are running a load test, you're running AWS Lambda, it can go to a massive scale, so you want to be very careful that you're not incurring too many costs. You need to be very careful about how you're configuring it and how you're running it. Start at a low level, understand how that's working, and then gradually ramp up. Don't put in massive numbers at the start and then be surprised at your bill at the end of the month. The components of a good load test, as we went over, are the exact replica of production, the observability tooling, the repeatable scenarios, the ability to simulate a very high scale, having realistic user flows. Things like synthetics are getting quite interesting to be able to do that, and I think that's an area that's going to be under quite a lot of development. Geographic distribution could be really useful in understanding how your regions are affected, especially when you're running a multi-regional architecture, and committing repeatable tests really improves the rigor that your team have to these experiments, the trust that we have in the results, but also allows us to do analysis. Maybe scalability's got worse for some reason. We want to understand at what point it got worse. And that's why if we have these isomorphic environments for integration testing on production, basic load tests can be run as a sort of pre-production job to make sure that we aren't impacting scalability. And as soon as we are, we can verify exactly what the cause was. I hope you've enjoyed the talk. If you have any questions, feel free to reach out to me. The slides are available on slides.com/Ben Ellerby. The Serverless Transformation blog, podcast, and newsletter are all out there, so feel free to subscribe. And we also run the Serverless London meetup where we cover topics like this, so feel free to come to those events, which are of course virtual at the moment. Also, Theodo help people build serverless architectures. If you're interested in how we could help you, feel free to go to Theodo, that's theodo.co.uk/expert/serverless, or just drop me a message via Twitter. Thank you so much for your time, and if you have any questions, I'll be available in the Q&A session.